Okay, so now we're going to work on Algebra Section 3.1 notes. So what we're going to look at is decoding graphs and what's happening. So we've got some keywords like was constant or stayed the same. And that would be typically when you look at a graph, that's going to be a horizontal line or a segment or a part of the graph that looks completely flat across. And then we have rose steadily, increases, and that's going to be a slanting upward. So it's going to be increasing, and the more that it increases, the steeper that's going to get. Then we have dropped sharply or decreases. That's going to slant down. And if it's more rapidly or accelerates, that's going to get steeper. So it may start off like this and then rapidly, so it gets steeper going down. So this would be the more rapid part. Or going up, it may look like, okay, I'm going up nicely, and then all of a sudden I'm going to increase that, and so it becomes like a sharper, a steeper going up. And then we have decelerate, so then it's going to get less steep. So we may be going really fast and then we slow down. Or we may be going really fast up and then we slow down, less steep. And that's our decelerates or less steep. So let's go ahead and take a look at what is happening in each graph. And the graph relates the number of leaves on the tree and time. So when I'm looking at my first graph, the number of leaves are increasing. So we've got more leaves. And then it stays the same for a period of time. And then all of a sudden, the number of leaves drops. So less leaves. On our next graph, we have the number of leaves are slowly dropping, and then maybe we have a huge windstorm and they drop like a lot faster. The number of leaves in the tree drops faster, and then it slows down with like maybe little gusts. So this one's faster, and this is slower. This is probably slowest because it's the least steep of the three segments. And this one is medium fast, I guess. Okay, and then our last one, we're losing leaves. And then we stay the same. And then we're losing leaves again. And it looks like these two parts of where we're losing leaves are pretty the same rate, because they look about the same steepness. So that's like the same rate or same speed. And so you'll notice with these graphs that the steepness is talking about how fast or how slow. The more steep it is, the faster we're losing leaves, or the faster we're traveling. The less steep it is, the slower we're losing leaves, or the slower we're traveling. So now we're going to take a look at these three graphs now that we've kind of talked about how they work. And we're going to figure out, well, which one matches our situation. So each day several leaves fall from a tree. One day a gust of wind blows off many leaves, and then eventually there are no more leaves on the tree. And so it looks like we never gain leaves. So this one is not going to be correct because that one started off with gaining leaves here at the front. And so we're losing leaves each day, so B or C could be fine. But it never says that we just stop losing leaves. So this one, the amount of leaves stays the same right there at that constant. And so that can't be correct. So this one seems like, okay, slow, and then big gust of wind, and then kind of a little slower. So graph B would be correct for this situation. Okay. Describe what is happening in each graph that relates to air temperature and time. So it looks like the temperature is staying the same. It increases, and then it decreases, and then stays the same. Okay, our next one stays the same, increases, stays the same, and then drops very sharply. Our next one, it increases sharply, stays the same, increase, and then decrease sharp. So the air temperature increased steadily for several hours and then remained constant. So this one was constant, constant. So increased steadily and then remained constant. Looks kind of like graph C. Increased and then constant. At the end of the day, the temperature increased slightly. So increased slightly and then dropped sharply. So it looks like graph C is correct for our situation. Okay, the previous graphs are connected lines or curves, and because they're all connected where I could really just take my pencil and draw the whole graph without ever picking up my pencil, that's what we call a continuous graph. So, for example, this one was a continuous graph because I'm drawing it without ever picking up my pencil. But we also have something called a discrete graph, and that's where we have only certain points. We don't know if there's other values or there are no values in between those. And so for an example, we have number of people. And the reason why number of people is not connected is because I can't have half a person. That just can't occur. So then we only have distinct points for one person, two people, three people, four people, five people. And what this is showing us is that the cost per person drops the more people you have. And you might find that true if you were going on vacation, that the more rooms you're booking or whatever, the price per room drops because they're wanting to reward you with that more business and booking up more rooms. So with each additional person in the group, the cost per person for the group trip drops. This is a discrete graph because it is not possible to have half a person or a third of a person. So there is no value in between the dots, and that's our discrete graph. And so we'll be dealing with those on and off most of the chapter, continuous graphs and discrete graphs. Okay, so we're going to go ahead and sketch a graph of this situation, and keep in mind that when we're sketching graphs, not everyone's graph is going to look the same, but as long as it follows the guidelines, that'll be okay. So we have a truck driver, drives at a constant speed, stops at a light, and then continues. Okay, so he's going to drive at a constant speed, and then he stops, so he slows down quickly and stops because now there is no speed. And then he continues to drive. So he's going to speed up and then probably go at a constant speed. And that constant speed is probably somewhere around the speed limit. Unless it's the Palmer-Wasilla Highway, then it's going to be 40 miles an hour. And then does your graph have to look perfectly like that? No. But as long as it follows those rules, we've got constant speed, which is a horizontal line. And then he's going to stop. So we're going to go down to 0 for speed. And then when he starts up, he's not going to all of a sudden go from stopped to 55 miles an hour. No, you've got to speed up and then you hit your 55 miles an hour. Okay, a small bookstore sold between 5 and 8 books each day for 7 days. So I've got a grid here, so I have to label it. So we're selling between 5 and 8 books each day. So I'm going to go ahead and put my days on the bottom. And I'm going to label how many days. 1, 2, 3, 4, 5, 6, 7 days. And then I'm going to label my other variable, which is books. I don't write very well sideways. And so I'm going to go ahead and label 1, 2, 3, 4, 5, 6, 7, and 8. So every day the bookstore sold between 5 and 8 books. So am I really having half a day? No, they're kind of talking about each day. So on day 1, I could have anywhere between 5 and 8 books. Day 2, anywhere between 5 and 8 books. Day 3, anywhere between 5 and 8 books. Day 4, day 5, day 6, day 7. Now your dots may be placed elsewhere, but as long as each one is between the numbers of 5 and 8, your graph would be totally fine. Because again, we're just sketching a graph that meets the situation. So everyone's graph could be different but still be correct. Okay, Jamie is taking an 8-week keyboarding class. At the end of each week, she takes a test to find out the number of words she can type per minute. She improves each week. So let's go ahead and put weeks. And we're going to have 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to talk about typing words per minute. And I'm not sure what the average word per minute is, but I'm going to go ahead and go by maybe 50s, or let's do 20s. So 20, 40, 60, 80, 100, 120, 140, 160. And so this is words per minute. And we're just looking at her improving each week. So on week 1, maybe it's only 20 words a minute. Week 2, maybe it's 60. Week 3, maybe it's 80. Week 4, maybe she jumps to 120. Week 5, 140. Week 6, maybe it's 150. 7. So as long as we're continually going up, that's okay. And then the question is, do I connect these? Well, since she's not taking the test in between the weeks, this should be a discrete graph. We shouldn't be connecting those dots. We're just looking at the pattern for those. Okay, Henry begins to drain a water tank by opening a valve. He then opens another valve. Then he closes the first valve. He leaves the second valve open until the tank is empty. So let's go ahead and put time down here. And I don't know how much time, but I'm going to go ahead and label 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to put water. So maybe like the amount of water. So I'm just going to go ahead and label it based on this. And again, we're just kind of sketching the idea of what's happening here. And we're not even going to label it as gallons or liters or anything else like that, because I don't know how much water it is. We're just using it to kind of gauge what's happening. And so we start off with the full amount of water at 0 time. He begins to drain the water tank by opening one valve. So maybe he goes down and the valve constantly lets out the same amount of water, so that change just stays going down 1/1 each time. Then all of a sudden he opens another valve. So now it's coming out 2 valves. So it's going to come out faster. So instead of this steepness, we want even faster. And then he shuts the first valve and goes back to the second one until it's empty. And so we're getting 1 valve, and then 2 valves, it goes faster, and then just 1 valve again. And so it should be that same pace as when we had 1 valve. And so getting an idea of how that might look. And again, we're sketching it out. Your graph may look a little different than mine, but that's okay, as long as it follows those guidelines.